Right, welcome everybody to set 19, paper 2, 3H. This is a calculator paper. I'm filming it in landscape mode 'cause obviously it works a little bit better online, but let's not waste any more time. Right, we've got two similar triangles. First of all, let's work out the length of BC. So, BC is the top right on the smaller one. Really important that we identify the scale factor first. This is worthy of working, so always state your scale factor by dividing the corresponding lengths. Be careful, sometimes they sort of flip the triangles reflect, but the triangle is similar, the corresponding angles are the same. So we're doing 12 divided by 4, that's 3. 3 is worth marks, meaning the triangle on the right is 3 times as big as one on the left. So go BC, I need to go the opposite way. So I'm dividing by that scale factor 3. So BC basically is 16.5 divided by 3. Calculate paper, so don't take any chances here. Just divide that with your calculator. That is 5.5 centimeters. Okay, well done if you got that right. It asks now to write an expression for y in terms of x. Well, as I said, to go from x to y, you times it by 3. So y, the size of y is basically 3 lots of x, isn't it? So we'll say y is 3x. Brilliant. Didn't need a calculator for that. Number 2, AB, right, this looks right angle triangle. We're dealing with lengths and angles. This is a trigonometry, right? SOHCAHTOA is what I'm thinking of. So with SOHCAHTOA, identify the sides. Right, it wants AB. Let me call that x for argument's sake. Call it any let you like. But with respect to this angle here, it's going to be, well, that's the hypotenuse and this is the opposite. So SOHCAHTOA, I've got the opposite and hypotenuse. I'm going to use SO or sine, right? So your first mark comes from saying, I'm just setting up the equation first, sine of the angle 65, always put the angle side sine, equals the opposite length, x, in this case, over the hypotenuse 8.4. That will get you one method mark. We want to move the 8.4 across, so second mark comes from 8.4, lots of sine 65, and then obviously type that in your calculator. Always remember, on your calculator, we probably don't think about it, but there should be a capital D at the top. That stands for degrees. Without going into too much detail, because it's more year 12 stuff, and 13, we only work with degrees at GCSE. So the answer you should be getting is 7.61 to 3SF. Yeah, if you get a different number, you might have the wrong calculator sentence. Talk to your teacher, and I'll happily look at that, or your teacher will. Okay, next up, we've got a probability tree by the looks of things. She's got 2 packs of seeds. There are 12 seeds in packet A, and 7 of which are sunflower seeds. So on my tree, I'm thinking there are 12 seeds in packet A. 7. So there's a 7 in 12 chance of getting sunflower seeds. There are 15 seeds in packet B, and 8 of those. So there'll be 8 over 15 for this branch. Now, obviously, if 7 are sunflower in the first packet, that means that 5 are. I've just taken 12 away from. Sorry, just taken away 7 from 12, and the same story here, right? So if there's 15 seeds in packet B, 8 of which are sunflower, then 15 take away 8, 7 will not be sunflower. Okay, and that'll be the true for the. We're just writing the same pair for the top and bottom, 8 at 15, 7 at 15. Okay, so that's 2 marks there. Calculate probably that she will take 2 sunflower seeds. Well, this tree has sort of, if we always start here, which of the sort of 4 pathways involve her getting 2 sunflower seeds? Well, it's literally only the first one, isn't it? It's sunflower on the first, sunflower on the second. So we multiply both of these probabilities together, meaning it's 7/12 for the first one multiplied by 8/15 for the second. Again, type that into your calculator. 7 over 12 times 8 over 15 is 14 over 45. Is your answer there. Okay. Next up, number 4. We've got Sarah makes and sells mugs. One day she makes 150, and we're given the total cost of manufacturing these. Of these mugs, 2/5 are small, 32%. Okay, right. All right, okay. There's a lot to go on here. So, do you know what we're going to do first? I'm going to work out how many small, medium, large mugs she actually made. Right, starting with 2/5 of small. So the first one, 2/5 of 150. That is, again, you can multiply the fraction by the whole number. That works. Or you can do 150 divided by 5 times 2. Both are going to give you 60 mugs. So 60 are small. We'll do something similar for medium. So you can do 32 divided by 100 times 150. You can even turn it to decimal if you really want. So you could do 0.32 times 150. They both give you 48. Medium. Now for the large, we'll just take these two numbers away from 150. So it'll be 150. Take away those two numbers. So take away 60. Take away 48. That leaves 42 large. So first thing I've done is I worked out how many of each have actually been made or sold. She sells everything, right? So we are going to do a bit of working now. So we need to do 60 times £8.50 plus 48 times 11.20 plus 42 times £14.20. Okay, I'm just working out how much money she's going to get from sales. So a lot of calculator pressing at this stage. You know what I mean? I would always recommend, because whenever you're pressing loads of buttons, this is when you're most likely to make a mistake. So I'm going to try this twice. So I'm getting 1,644. That's her total sales. So that's money in the till at the end of the day. But just to be extra careful, I am typing it in twice, right? This is good practice, because, even the pros get this wrong. Yeah, I'm getting the same number. If you get the same number twice, then that's a good sign. Cool. Now, percentage profit. Remember, any percentage change, or, percentage profit is a kind of percentage change. We always do this, right? It's change over original times 100, right? So, the examiner will want to see you using numbers here. So how much has your money changed by? Well, she spent 1,140. So we'll do the 1,644, take away the manufacturing price, because that'll be the change. How much has her money increased by? Over the original amount, which is the 1,140. Okay. And all of this will times by 100, right? That is the bit of working the examiner wants to see. So last bit now, calculator. 1,644, take away 1,140, all divided by 1,140, gives you 0.442. Again, times it by 100 to change it to a percentage. If you calculate as a fraction, obviously work it out as a decimal. I'm getting 44.2105 ... which to the nearest whole number would be 44%. Okay, let me confirm that. I've got the answer sheet in front of me. They're happy with that. Good. Number 5, moving on. Okay. Lowest common multiple of 28, 42, and 63. What you can do, and what will make your life a million times easier, is just to pick any two of the three, right? Let's just work out the LCM of these two numbers. I can do that by just thinking of my times tables. You can do the Venn diagram method. It is a bit more sort of formalized, but for sort of performance purposes, I'm just going to do my 28 times tables. So it would be 56 next. 84. All right, I think 84 is the second number in this times table. So we know that the LCM of these two numbers is 84. So what you can do now is just work out the LCM of 84 and 63. And you'd be inadvertently finding the LCM of all three numbers. Okay, so let's do just that. So let's compare 84 and 63. If I do my 63 times tables, the second number would be 126. If I did my 84 times tables, it would be 168. Okay, we're going to have to go a bit more further on the 84 times tables. It's nice because obviously we can just add numbers. The next number along would be 252 here. Let's do the same for the 63 times tables. 189. Oh dear, is this going to be a long one? 25. All right, no, we're good. So we got 252 on both, right? For me, if you're doing the Venn diagram method, you should end up with that, right? But to be honest, this is going to get 4 marks. And yeah, we're done. Right, next question. So number 6, we are now on. Cumulative frequency running total, right? 80. Now, I can guarantee you the last number is going to be 80, right? But that'll be the way we check our answer, right? So running total, right? First number's the same. Second number is 7 plus 26, right? So add the numbers together. 7 plus 26 is 33. Okay, then the next number I add is 24. So we're going to add that to our previous number of 33, gives me 57. I can then add 14 onto that, which would give me 71. Plus 7 is 78. And obviously plus 2 at the end is 80. Okay. Right, the next one's going to be a cumulative frequency graph. So remember, you always pick, on that table on the previous page, you want to make sure you're using the right value as your x-coordinate. Right, don't choose a midpoint. It's always the value to the right on a cumulative frequency graph. So this question 6. Okay, so starting with 10, we've got 10 goes with 7. 20 goes with 33. Make sure you're accurate. 30 goes with 57. Last few. 40 goes with 71. Up here. 50 goes with 78. And last but not least, 60 goes with 80. Now, with a cumulative frequency, please do not, under any circumstances, use a ruler. Freehand, please. So draw a smooth curve. Sometimes it helps to rotate the page. But do not. None of this I'm doing with a ruler. So you should be the same. It's freehand. If the examiner sees you use a ruler, you will lose a mark. Okay. They don't mind seeing like wobbly lines like I've drawn here, but they do mind seeing straight lines. That is a -1 mark if you did that. Now median, you should remember median is sort of like lining everyone up and finding the middle person. So here there's 80 people, so the middle person will be divided by 2. It's the 40th. So this bit you can use a ruler for, go across and then down. I'm not using a ruler just because iPads are difficult. But I'm doing my best, right? And it's 23. You are allowed to sort of be one box on either side, so 22, 24, give yourself the mark. Okay, but the median is 23. Next up, D, we've got to estimate the probability of the time taken by this customer is more than 42 minutes. So x-axis, 42 is there. We're going in reverse. Right, up we go, up we go, up we go. I'm being super careful. I would usually use a ruler for this, but again, iPad and whatnot. Go across. I'm pretty confident we're going to end up at 73. So what this means is 73 people or less do it in under 42 minutes. So more than 42 minutes. Remember, our total's 80. So that's going to be 8 people, isn't it? Right. Now, the question is not, if we get too excited, it's not 8. probability, well, it's 8 people in total. Sorry, there's 8 people more than 42 minutes, but there's 80 in total. So we need to write that as a fraction, 8 over 80, which simplifies to 1/10 or 0.1. Okay, they would accept. I'm pretty confident any 3 of these. The mark scheme I'm looking at says 8 over 80, so they don't even care if you don't simplify it because they don't ask for it, but always good practice if you do. Right, number 7, we've got simple probability here. We got different kind of sweets. The ratio of number of pink to white sweets is 2:1, so we want this answer to be twice as big as white. Now, what do we know about probability? We know all numbers add up to 1, so let's add these two, 0.55. We'll do 1 minus that, which is 0.45. We know that both of these pink and white combined will be 0.45. The ratio means there's 3 parts. We will divide 0.45 by 3, which is 0.15. And that'll be the white part, right? So 1 part of my ratio is 0.15, meaning pink will be twice that amount, so it'll be 0.3 or 0.30. I'm not going to write the second 0, it's not necessary. So I've done the table. Let me read the rest of the question. There are 28 red sweets in the bag. Work out the number of white sweets. Okay. So if we think about probability, think of this like as 35%, I guess. 0.35 as a percentage. There's other ways to think about it, right? But I'm thinking 35% is 28. You can write it as a decimal if you really want to work in decimals. So if I divide by 35, I'd be working out 1%. So we'll divide by 35. This will be a decimal, perhaps. So you get 0.28. I mean, no surprise there. And then you times by 100. My bad. Sorry, I did a mistake there. I was not meant to divide by 100. I was meant to divide by 35. So that would be wrong. So 28 divided by 35 is 0.8. And then you times that by 100, right? So times 100, 100%. The whole bag has 80 sweets, right? Total. Again, there's other ways to get 80. But when it comes to the number of white sweets, we want 0.15 of 80. So the last step is you multiply you can even think of this as percentage. So the number of white sweets is 0.15 times 80, 12. 12 white sweets. Nice. Moving on, I've got time for one more. That's not really going to make sense to you because it's a video and I can stitch it together. Number 8, put some respect to my name, please. Number 8, Daniel, Gabriel, Hadley, sharing some money. Okay, so this is a difference in ratios. This is not, and do not fall for the trap of doing 196 divided by 3 plus 5 plus 9. This is not that question. So, right, let's see. Daniel, Gabriel, and Hadley, DG and H, they always follow the same order in ratios. The difference between the money Gabriel, who gets 5 parts, and Hadley, which gets 9, is 196. So what we're going to do is we're going to take away their parts. So this means this means 4 parts of my ratio are represented by the amount of 196. So what I can do is I can divide that by 4. So each part of my ratio, 1 part, is exactly 49 euros. So what you can do now is with your ratio 3, 5, and 9, just times them all by 49, and you'll have the total amount each person gets. I haven't really even read the rest of the question yet, but the examiner likes to see this. This working, I'm sure, will be useful. 2, 4, 5, and 9 times 45 is 405. So that's how much each person gets. Daniel, Gabriel, and Hadley. You can check if you're doing it right. You take away Hadley and Gabriel's amounts. That should equal 196. If it doesn't, in your exam, work out where did you go wrong. So look, I'm just quickly checking. 405 take away 245 is not the right answer. So, again, this is me checking my answers, right? I've made a mistake somewhere. I'm getting 160. That's not 196. That is worrying. So let me go backtrack. I suspect I didn't times one number by 49 well enough. 9 times 49. Yeah. Here's a mistake. Hadley's bit was wrong, wasn't it? I should have written 441. And again, that's the habit you want to get in. Since I've made a mistake once, I'm gonna just check Daniel's amount because I think I accidentally maybe have times it by 45 by accident. These mistakes happen, right? Yeah, he's 147. Daniel gets 147, right? So that's his amount. I'll double check the mark scheme just to triple check here. But yeah, 147 is the correct answer. Okay, right. Question now. We've got Jenny has 6 cards, or Janai, as a very famous American once said. Each card has got a whole number written on it, so that the smallest number is 5, largest number is 24. Okay, those two are already written down. The median is 14, and the mode of the numbers is 8. She arranges the cards so that the numbers are in order of size. Okay, it's a real challenge here, right? So, first of all, what I'm thinking is the mode being 8. All right, that means that 8 has to happen at least twice. Remember, mode is the most common. Now, the median of the number is 14, right? So there's 6 cards. We're going to presume we're going to write these all in order. So 14 would be sort of the midpoint of the sort of both numbers on either side. Now, we also know there's got to be 8 happens twice. So we can write 8 once, 8 twice. It can't really be 3 times because that would affect the median being 14. So twice, we know for sure. Now, 14 being the middle number of 8 and another number. So think about sort of midpoint in reverse. 14 is halfway between 8 and what other number? I mean, there's 2 ways you can work it out. You can say, right, 14 take away 8 is 6. So clearly, if 14's in the middle, the next number along has to be 6 higher than that, which would make that 20, okay, because 14 has to be the median. Let's see. I think we've almost done it. We just need to think of that sort of 5th card along the list, right? I think you've got a bit of a freedom to choose here. It can be sort of 20, 21, 22, 23, or 24. I'm looking at the mark scheme here. It is saying 21, 22, or 23. In fact, we can't say 20 or 24 because then that would make 20 or 24 another mode. And we want to make sure it's 8 is the only mode here. So yeah, don't write 20 or 24. It has to be 21, 22, or 23. You do have a choice of these 3 numbers. Okay, that's A. Looking at my mark scheme in front of me, it says you get 1 mark for a list with a median 14 or a mode of 8, or the 3rd and 4th card having a sum of 28. I'm not going to talk about all the different mark schemes. I will post that online, so do have a look at that, or do ask me if you have any questions, but that's for the 3 marks. Next question. A basketball team plays 6 games. Right, after 5 games, the mean score is 21. After 6 games, the mean score is 23. Okay, so this can kind of be combined. So if you want to look at more questions like this, do look at combined means or reverse means. They're kind of similar topics that get taught hand in hand usually. The best way to think about this is the first 5 games. If we tally up sort of all the total scores, first 5 games total, you would do 21 times 5, right? 105 points. So that's what you would get on the first 5 games in total. Now, the first 6 games in total would be 23 times 6, right? Because if the mean is 23, that means on average each game is scoring 23. If we want to know the total, we just multiply the numbers, so 138. Now, obviously, we got to ask ourselves, well, from the 5th to the 6th game, how much do the total points go up by? Well, we take these two away, and obviously the difference will be how much you scored in that 6th and final game of yours. So 33 points is the answer here on the 6th game. That was how many were scored. Let's now look at number 10. Again, I'm just quickly checking the mark schemes because I don't want to make any silly mistakes on this video. Number 10, right, 33 was correct. Average house price, right, year on year. So we know the average house price for 2018 and 19, but not 17. The percentage increase from 18 to 19 to 1 is placed. Right, any percentage change, and this includes percentage profit. The formula is always the amount change. So how much has that price gone up or down by? Because sometimes we can have percentage decrease. So this works for going up and down over the original price. Okay, so this is time. When I say original price, I mean at the beginning. So you've got to think about time. Because when, prices go down, the original price is always more. So always the original price, always the start price goes on the denominator. And we times it by 100, right? So let's start substituting. So how much did this change by? It changed by that minus that, right? 2, 3, 1, 7, 7, 6. Take away 2, 2, 8, 3, 1, 4. Right as a fraction over the original price, right? 2018. I know it's 2017, but this has nothing to do with this question. We're being asked, so the original price is the 2018 one. Right, I'm doing a bit of calculator pressing right now. So I'm taking away 228, 314, and I'm going to write that as a fraction. Over 228, 314, and then I times it by 100. Okay. And what I'm getting is a bit too high of an answer. My calculator, I'm getting 1.51. This makes no sense. Let me try this again. What I've most likely done is I pressed the wrong button somewhere, so bear with me. These things do happen. Again, like I always say, if you've got a lot of button pressing going on here, especially if something doesn't look all right, don't feel afraid to spend a few seconds typing away again. I did in my working forget to write times 100 at the end there. That's really important. I should add that. Okay, and no, I am getting the same number, so I'm getting 1.516 ... I see no mistakes with my number, meaning that it has gone up by just over 1%, right? So 200 place 1.5%, okay? I say that, I should have just checked my mark scheme in front of me. Okay, yeah, it's 1.5. B. Okay, so the average house price in 2019 was 7.7 greater than 2017. Right, let's look at the times. This is reverse percentages. We are going back in time. The percentage change has already happened, right? So some number has been increased 7.7%, and the result being 231,776. Various ways you can write this out. I always like to use the multiply method. So again, if this is something you struggle with, do look at reverse percentages. I'm going to say some value of X. Okay, this is the 2017 price. You use any letter of your choosing. We've increased that by 7%. Okay, so I'm going to think about the multiplier. Okay, so this is a 7.7% increase multiplier, which, the way you work out in percentage increase multipliers is you always start with 100, you add 7.7%, and then we're going to change this into a decimal, right? So you move the decimal point 2 places to the left, 1.077. Do that. Okay, 1.077. Now, usually, like, if you are good with multipliers, you know that when you multiply these two numbers together, you would then get the answer which we're given, 231,776. 231,776. Cool. So we've now got an equation with X. This is a fairly easy to solve equation when you've got a calculator. So all we've got to do now is to find x, the original price. We just divide. Now, sort of mental things I always think about when I'm solving these is, remember, with reverse percentages, the price has gone up, right? So we're expecting a value less than 231,776. If you're getting a number bigger than that, that's a massive red flag. Go back. Did you accidentally multiply by 1.077 instead of dividing? It happens to all of us, okay? But having these sort of mental checks in the middle of an exam is going to only help your chance of getting that top grade, all right? Now, my calculator's saying 1996 at the end. With money around to either the nearest pound or nearest penny, they've asked for 3SF. You know what? Let me write down the whole number. I know money's only 2DP, but it's fine because we need around to 3SF, don't we? So to 3SF, right, we've got the 100,000s, the 10,000s, and the thousands being the third sig fig. We're around to the nearest 1,000. Which would be 215, right? So that's my final answer. Very nice. Let me just double check the mark scheme. I've got to get in a habit here. Last paper I did, I made one or two silly mistakes. And you know what? If I'd have checked the mark scheme, I would have spotted them. Okay, that was good. Mark scheme agrees. Number 11. Okay. Let me have a little sip of my coffee. Okay, brilliant. Here we go. We've got a frequency table. Now, this is called mean of a frequency table, if you want to know the topic name. Questions are usually a little bit easier than the one we're looking at, but I'm going to talk you through what we do, right? Because the steps would be the same, be an easy or hard question, right? Just involves a little bit of algebra, it makes it a bit tougher. When we're dealing with mean of a frequency table, usually they include this column fx. Some years they do it, some years they don't. Tougher years they won't. So here you go, you got a tough year. We need to multiply all we call this column frequency f. That's always called f, amount of things, how often it occurs, frequency. And then we've also got a number of points, right? Now, the thing we could be measuring could be different. It could be number of points, could be, number of brothers, number of sisters, number of students or whatever, right? Actually, that's a bit confusing what I just said, number of students. But usually when we're measuring something, okay, it could be, temperature, could be age, could be anything, right? We call that x. We generalize, right? Because it could be anything. fx, basically, we're multiplying all these pairs together, right? So ask yourself, why are we multiplying this, right? Well, look, we've got all of these players, right, in this column. We don't know how many players got 3 points, right? But what we're asking ourselves is, well, if I asked every player to put all their points in a bag, how much would they have in total? Well, these 13 players we begin with, they would have 13 times 0, which is 0, right? Makes kind of sense, right? All 13 players didn't score any points between them. So in total, no one got any points in that group of 13. Next up, we got 17 times 1. So 70 players got 1 point each. So in total, those 17 players got 17. The next 8 players got 2 apiece, so they got 16. This fourth row, I don't know, but I know that if I wanted to know the total points, I'd take 3 and multiply it by x. So we'll just leave it as 3x for now. And the bottom row, we would get 44 points, right? All 11 players got 4 each. Cool. All right. Then, what we would usually do, because usually we wouldn't have x in these sort of questions, and it would be about 2 or 3 times easier, I think. I did make that number off the top of my head there, number 3, but it would be a lot easier. I hope you agree. Usually what we'd do is we'd say, right, let's add all the points from all the different players, right? We call this sigma fx, right? Sigma means we add them up, right, in maths. You may know this from the whole meme of sigma, okay? Maths, it means something else. Although if you can use sigma, you are very sigma yourself. Anyway, let's add. So we're going to add all of these. Unfortunately, we've got 3x in the mix, so I'm going to just add the numbers I know. So 17, 16, and 44, which is 77. So I've added this, and this, which gives 77. Unfortunately, I don't know what 3x is, so we'll just say the total here, 77 plus 3x, is the total there. And the total frequency, which we'll also need, is 13. Again, I'm adding everything besides the letter x because obviously that's an unknown. And I'm getting 49, right? So 49 plus x. Usually to get the mean, we do sigma fx, which is this thing here, and we would divide it by sigma f. Sigma f meaning the sum of frequencies. So that. Now, it's tough because we're going to have a fraction, right? We can't really divide these things. We've got x in the mix, and that does make it a bit more challenging. Okay, but that if you did this, the answer would be the mean, which we are told is 2. It tells you right there in the question. So we've now got an equation, okay? And we need to solve it. So let's do just that. Okay, so I've got an equation. How am I going to do that? How am I going to solve that? Let me scroll down. Well, I'm going to start by multiplying both sides of my equation, left and right, by the denominator on the left-hand side, right? 49 plus x. Why am I doing this, you ask? Well, if I times the left-hand side by the denominator, the 49 plus x on the top and the 49 on the x on the bottom would just cancel out, wouldn't they? You know, that and that would be gone. But on the right, I would, it would move sort of across, wouldn't it? So you get 49 plus x. On the right still. So my first line of working, and we will need to use brackets here because we are multiplying 2 by both the 49 and the x, would be that. Cool. Now, we're going to expand the bracket on the right. So let me rewrite 77 plus 3x. Cool. And I'm just multiplying out the bracket. Okay, so 2 lots of 49, 98. And 2 lots of x, 2x. Okay. Oh, I wrote 1x. That would be a mistake. 2x. Okay. All right, now we're going to solve this. So we're going to subtract 2x from both sides of the equation, because if I do that, these two cancel out, leaving me with 77 plus, well, just 1x, or you can just say x on its own, equals 98. And then we're going to subtract 77 from both sides. Because those two would cancel out, and we would be left with literally 99, take away 77, x equals 22. So the answer to this question is 22. Now, I am relieved. I'm pretty convinced that this is the correct answer. One thing that should give you confidence is frequency must be whole numbers, right? How many of these people had that point, right? If you're getting a decimal, does not make sense. It'll be a huge, huge red flag. But because we're getting a whole number, that is reassuring. I mean, there's no guarantees that is 100% the correct answer. I'm looking at my... Oh, dear. Now, of course I made a mistake. Of course I made a mistake. It's 21. I can't believe it. How did I get 98 take away 77 wrong? It's because I trusted my calculator and I typed it in the wrong number. So it is 21. Did make a little slip up there on the last line. That would have probably cost me 1 mark, but certainly no more. 21 was the right answer. So if you were sort of panicking because I got the wrong one there, I did catch it before that. Number 12, right, Himari is an investor by the looks of things, and is investing quite 200,000 yen for 3 years in a savings account, paying compound interest. Keyword compound interest. Okay. And we're given the okay. All right, so Himari is investing here. Don't know if Himari's a boy or girl's name, but anyway, look, they're investing money, and again, this topic's called, well, I mean, compound interest will give you loads of stuff online. Repeated percentage change is also another one. But having a good grasp of multipliers is going to be crucial. Okay, so let's think about it. Right, originally, Himari has this much, 200,000 yen. Little bonus point if you knew the sign for yen was that. And we're going to multiply that by 1.8% increase. Now, as a multiplier, that'll be 1.018. I've explained the multiplier in a previous question. Again, find out more about the multiplier if you're not sure where I'm getting 1.018 from. Now, we're going to multiply, that's the first year. In the second and third year, they use X% here. I'm not going to use X. I'm going to come up with a different letter Y. Now, why am I not using X? Because X% change. I want to say Y is the multiplier for an X% increase. Okay, so don't worry. You can make up your own letter. I'd avoid X just because that's a different value. But we're going to say in the second And third year, there is an identical multiplier every time, right? We just don't know what it is. But if you multiply by 1.018 by y, and you do that with 200 grand, you will at the end receive 754 yen. Right, cool. So I've set up my equation. So let's solve it, right? To make your life easier, we can call this y squared, because it is. And what we'll need to do to solve this equation is we're going to divide by that and that. I mean, we can divide by both in one step. You can do this in multiple steps, but yeah, remember we are multiplying by both 200,000 and 1.018. Be sure to make sure your 1.018 is on the denominator, right? So we'll get an equation for y squared here. If we do that, 209,754 divided by either use brackets or fraction button's probably better here, because we want both the 200,000 by the 1.018 on the denominator there. Right, I'm getting quite a long number here, so I'll write it out in full. There is no harm. If you can write the whole number out, I would recommend it very much, because then you don't do rounding errors. If you keep sort of rounding, working as you're going along, you do run the risk of rounding errors here. And I'm going to square root that, right? Remember, this is y squared. We want the yearly increase, don't we? We want x. So if I do that, I'm getting 1.01500046. Okay. Now remember, this is the multiplier. This is y. So you got to kind of think of something along the lines of 1.08. Remember, that's 1.8%, isn't it? It's the bit sort of ignoring the 1 at the beginning that we want. Okay, we want to sort of ignore the 1 point. We want to look at this bit here. Okay, this bit here. Because the 1 at the front means like you keep your 100%, but you add the 1.50046% on, don't you? So at this point, you can kind of, if you just take that bit of your number, of your multiplier, you can say, well, x equals 1.50046%. To one decimal place would be just 1.5%, wouldn't it? So that's the answer there. Just going to check the mark scheme, because I almost got caught out on number 11, didn't I, with the one place value out. But no, it is 1.5%. I got that spot on. Let's move on. Number 13. I was about to say direct proportion. This falls under a massive umbrella called proportionality. You got to know direct proportion and inverse proportion. And they both are really sort of, we follow very, very similar steps besides sort of the first one. I'll talk a bit more about that now. So, do you know what? Let's do green. We are marking after all. Now, inversely usually means 1 over. So what I want to do first, with these sort of questions, we'll do an argument of proportionality. So that's where we'll see the little fishy sign. And what we're saying with this is we're saying A is inversely proportional. We're just using the special mathematical symbols, right? So like I said earlier, with inverse, it is usually 1 over, and then whatever they're saying it's proportional to. So anytime you see inverse, always do the letter, fishy sign, 1 over. If it's direct proportion, there is no 1 over, it's just the letter. But here it's c squared, isn't it? So A fishy sign, 1 over c squared. That's the argument proportionality. That's worth 1 mark, believe it or not. And my second line of work, and we are going to literally copy that. But now we're actually going to write an equation. Now, it won't always be perfectly A equals 1 over c squared. That is not always the case. There'll usually be some number connecting these two, and we call that the constant proportionality. Okay, we represent that. We say, look, it's not always perfectly 1 over c squared. Sometimes we need to multiply by some number, okay, that never changes. We call that k. Right, it could be 1, it could be 2, it could be 3. We don't know. We call it k. And that's for direct, that's for inverse, that's for everything, right? There's always going to be this k involved, no matter what. So don't ever forget to do that once you sort of turn your fishy sign into your equation, okay? Now the mark if you got that. Sometimes they forgive you if you skip the first step, but always do both, right? You never know what the mark scheme will be this year. They could get really fussy with it. Okay. You'll notice I've not even read the bottom line. I haven't read past the second, third line yet. 'Cause I always know that these are worth marks, right? So look, I've got my equation. Let's read ahead. You are given a fact. You are told when A is 40, C is 1.5. Okay. Well, that's really useful because if you substitute those two numbers in, you'll know exactly what K is. Yeah? We know A and C aren't perfectly connected with the number one. There's some number involved. So let's do that, right? Sub your values A and C in, and we'll get an equation. Okay, so the A is 40. K we still don't know. 1 over 1.5 squared. Okay, cool. Well, look, we can solve this really easily, right? With a calculator. We just times across your 1.5 squared. So to work out K, it's just 40 lots of 1.5 squared. Nice. So get your calculator ready and just type in 40 lots of 1.5 squared. Okay. If you do that, you guessed it, more marks are coming your way. And I don't think this is that hard, right? 90. So you know your value K. The good thing about this, the constant proportionality never changes, ever, throughout the whole question. Don't matter what A is, don't matter what C is. Those two change, but K always is 90. So what we can do is we can update, not that, sorry. We can update that. I'm going to rewrite the same equation, A equals, but you know what? Instead of K, I'm going to write 90. 90 times 1 over C squared. Nice. Some people like to write 90 instead of the 1. You know, you can bring the fraction together on the top right. I mean, a little bonus point if you wrote this. Okay, don't panic if you wrote that. They're both the same thing. And, you know, it's my style, right? You're watching my video, you got to get used to my style, right? So, cool. We've got that. I'm going to go with this. Now, the bottom line says, what is C when A is 1,000? So get your equation, change A to 1,000. We're going to have to do a bit of jiggling about, right? That is not the technical term. Please don't use jiggling in an exam. That would probably not bode well for the examiner. Rearranging is the correct term. So we're going to rearrange this equation. You're going to multiply across your C squared. So we're timesing both sides of the equation by C squared. Again, you don't have to demonstrate that's what you're doing, but you're doing just that because then the C squares cancel out the right. Then you're going to divide both sides by 1,000. Yeah, don't say jiggling. That's never good. So C squared is 90 over 1,000. I mean, the numbers look suspicious. I mean, you simplify your fraction. It's 9 over 100. Happy days. These are both square numbers, aren't they? 900. Do you know what? You could do this without a calculator if you want. So C has to be the square root, doesn't it? Of 9 over 100, which is 3 over 10 now. With direct and inverse proportion, usually it's for strictly positive numbers. The mark scheme does allow you to say both positive and negative. They do sort of forgive you if you don't consider negative, right? Because again, you know, if they haven't said if it includes negatives or not, they're usually quite forgiving. But in theory, C could be plus or minus, right? Because if you square 3 over 10 or you square negative 3 over 10, you get you would get a positive 9 over 100 either way. So that's your answer there. So again, you can write 0.3 and minus 0.3. The mark scheme does allow only 0.3. You don't have to go negative, but if you want to be super safe, go with both, right? No harm there. Okay, number 14. We got what? Lower bounds of A. So lower bounds, upper bounds, think of it as rounding in reverse, right? We call this limits of accuracy or bounds. Okay, so do search both of those two terms up if you want to know more about this particular topic. So bounds, limits of accuracy is the topic in question. Let's get on with it, right? Number 14. So, okay, lower bound of A. What this means is what is the smallest possible value of A? So you're allowed to... Okay, before I get to what this means, let's think about W, right? So we've got three different letters, three different ways that they could be rounded. So we'll start with W first. W has been rounded, and as a result, we've got 3.45. Okay? We've rounded to 2dp. So what the question you've got to ask yourself is, what's the biggest and what's the smallest number it could have been before it was rounded? I mean, look, this I usually wouldn't bother with in an exam, but because obviously you're watching a video and you want to know more about this, I always think about number lines, right? If I thought about two decimal places, which is not tenths but hundredths, if I was going up in the hundredths, we would go 3.44, then we'd go 3.545, 3.46, and then 3.47. Now, I'm not going to bother with the other two. I'm not going to go any further. But look, we're told that some number has rounded to 3.45. Well, it has to be bigger than this, because if we think about a number line, if it's smaller, it would round down to 3.44. And obviously on this end, it has to be smaller than sort of the halfway point between 3.45 and 3.46, because we want it to round to that, don't we? This is W we're talking about. So I'm asking myself, well, the number halfway between 344 and 345 is 3.445. And the number on the right is 3.455. Okay. Those are my limits of accuracy. Oh, sorry. Yeah, my bounds, beg your pardon. Yeah. So we can write an inequality. We can write an inequality for W, and we can say that W is either 3.445 or greater, right? Because if it was exactly 3.445, it would go up to 3.45 if you round it to 2dp. If it's any smaller than that, it would round to something smaller, wouldn't it? Now on the right, I'm going to say it's strictly less than 3.455. Yeah? Notice I haven't written the extra arrow here. The reason I haven't done that is because if it was exactly 3.455, it would actually go to 3.46. So by me not putting the extra line underneath, I'm saying, hey, look, this is the upper limit. We can get extremely, extremely close to 3.455. You know, for example, you could write 3.4549999 ... which is extremely close, but not exactly. Okay. Now, obviously 3.4549999 looks messy. So again, if you do write this with enough decimal places, exam boards usually allow it, but it's always better, and more mark schemes will just say 3.455, right? Even though I know it goes up to 3.46, right? But the extra arrow kind of lets us off the hook. Cool. Where was I? Right, so I'm not going to draw diagrams for every single question like that, but I am going to do something similar for X and Y. Now, X got to be a bit careful with, because the way it's been rounded is not 2dp but 1. So the lower bound is 1.85 and the upper bound is 1.95 for the similar reason. And Y, because rounded to the nearest whole number, is going to be 4.5 and... oh, let me draw the extra lines on there. And 5.5. Cool. So you'll get marks for writing all three down, right? So do that. These are bounds, right? So coming back to the original question, what A is, I'm allowed to mix and match any values of W and X and Y as long as they're within those range of values. So I can pick any value of X between 3.445, 3.455. Cool. I can choose any value of X between 1.85, 1.95, and the same for Y, right? 4.5. So, okay. Lower bound means this. What's the smallest possible value of A I could get by carefully choosing the right values of W, X, and Y, right? What's the possible minimum value? Well, in order to get that, I would want to start with the smallest possible number for W, wouldn't I? Right? So to get, again, remember, I want the smallest answer, the smallest possible answer. you want to start with the smallest possible value of W. So in this case, the smallest possible value of W would be the left-hand side, be the 3.445. Take away. Now, when you're taking stuff away, remember, we want A to be as small as possible. So that means I want this, because we're taking this away, not including the minus sign, I want that to be as big as possible. Right, so when I take it away, my answer will be even smaller. Cool. Now, with fractions, if we want it to be as big as possible, we want the biggest possible numerator. I want, usually when you're dividing stuff like x squared and y squared, I want the top number to be as big as possible. But I want the bottom number to be as small as possible. So let's say, well, the biggest possible numerator available is 1.95. I know you're not allowed to actually choose. Yeah, I know it's not actually allowed to be 1.95, but for the purposes of this question, it is the limit. So you are allowed to use 1.95 squared. Don't use 1.949 recurring. It's going to be a nightmare. You are allowed to use that number. Divided by the smallest possible value of y. In this case, 4.5. Right? Because when you divide stuff, the smaller you divide by, the bigger your answer are. Remember, we're taking this away. Cool. So these are the 3 correct numbers to have chosen. And let's go and do a little bit of calculator work. So I have spent a long time explaining this. This is one of the harder questions when it comes to bounds and limits of accuracy. But there we go. The answer we're getting is a fraction 13/5. So you can write as a decimal if you want. I mean, 2.6 works just as well. Is your bound. Okay, that is the smallest possible answer you would be able to get. I'm just checking my mark scheme. It agrees. Very good. Okay, right. So next question, number 15. We've got a circle. And ABC are points on the circle, so that the length of arc ABC is 5 centimeters. So arc length, remember that's sort of it's like part of the circumference. But yeah, that bit there is 5 centimeters. Fair enough. ABC. So the length of the arc ABC is 5. Given the NYC is 55. Work out the area of the circle. Okay, so all right. So this topic is called arc length. It sort of goes hand in hand with sector area, so be familiar with both. If you know the formula for the area of the circle and circumference, you're going to be really good at this, all right? Always think, I don't have the whole circumference, I only have a fraction of it. Now, I know the formula for the circumference of a circle is pi d is one of the formulas. I prefer to say 2 pi r, right? Because you can sort of replace pi d, the diameter is basically equivalent to 2 radiuses. But I prefer this one. So circumference is usually 2 pi r. I know that we're only given the sector area. Now, sector area, arc length. Now, arc length takes that and it says, well, it ain't 2 pi r, is it? We've only got 55 degrees out of a possible 360. So let's just write that as a fraction, right? 55 out of 360 multiplied by whatever 2 times pi times r the circumference would be. Now, we are lucky that we are told the answer to this. It's 5, right? So we know that if we went in and replaced the value of r with whatever it was, which we don't know, we get an answer of 5. Cool. We can solve this, right? It's an equation, and the only unknown is the letter r, right? Because remember, pi is just 3.14, etc. Cool. Do you know what? Let's start by tidying up the left-hand side, right? Does 55 over 360 simplify? It should do. Yeah, it's 11 over 72. And we need to multiply that by 2 as well. So you know what? I'm going to take all of these bits here and just simplify that to 11 over 36 pi, which equals, pi r, beg your pardon, don't forget the r, that's very important, equals 5. I'm going to rearrange this equation to make r the subject. So that means I'm going to multiply across the 36, so that'll be 5 times 36, and then I'll divide by both the 11 and the pi. So I can just do this as 11 pi. So I've kind of moved this across to the numerator, and I moved these two numbers, 11 and pi, down as a denominator. And that's my value of r. That's the radius. Now, you're probably wondering, why am I not sort of just giving you the decimal? I'm not going to do that. I like to keep pi. I like to keep things in terms of pi. I like pi. Who doesn't? But yeah, let's keep it as that, right? Why do I like it so much? Well, there's no rounding errors. So yeah, if you're gonna work out R and round that and then do the area, you could get rounding error. I don't like that. Okay, we're almost done now. Now, last step, area of the circle. Pi r squared. Sounds like area to me. If I use circumference, I'll just use pi d. If you don't know that banger, I implore you, look up the Circle song on YouTube. Great banger. Play it at your next birthday party. You will be the coolest person. I promise you. Okay, right, look. We're now going to replace radius with that number. I use brackets. You should too. All squared. And we'll just give the answer to 1dp, right? So shift pi multiplied by, put in brackets, 180 over 11 pi, close brackets, and don't forget to square it. I'm getting 85.233 recurring, so 1dp will be 85.2 centimeters squared. I'm just going to confirm that with my answer sheet, which is, please be right. Yes, it is. Brilliant. Keep going. Number 16. Right, a lot of people asked me about this earlier in the week. I hope I am going to give you a great answer here. So number 16, a zip wire. We love zip wires. And okay, before I get started, this topic is obviously, if you spotted the trig, yes, it is. Sokotoa will be something we're looking at. But more specifically, because obviously Sokotoa comes in many shapes and sizes, look up angles of elevation / depression. Now, depression here, not that this word should come across your mind when looking at a maths video. Depression also means it's like the opposite of elevation, right? It's just, most people think of elevation as going uphill. Depression in this context means going downhill, which is shown. All right, so we've got a zip wire. AC, okay. The zip wire makes an angle with the horizontal, blah, 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 blah. It needs to be at least 5 degrees. Work out the least possible height of AB. Okay. The first thing I'm thinking about is, let's make a triangle here. I see you, triangle. I see you hiding. Yeah. But we've found it. That's the triangle to use now. I'm sorry I don't have a ruler. But there you go, right? That's what you get for writing on an iPad. That is a right angle triangle. I know it's very hard to, yeah, there's me making it better. But yeah, look, you've got to sort of spot these triangles hiding in plain sight. Okay, so what do we know about this triangle I've just drawn in blue? Yes, A, it's very bad. But more importantly, what is the length here? It's 12. And the height, we don't know. That is something we're going to need to find. Now, obviously it says at least 5 degrees. So let's consider x is exactly 5, right? What would this be? I'm going to use Sokotoa right now. I'm going to copy that out below. Not to scale, of course, but just so it's a little bit easier to follow. So remember, I've just said that's 5. We know this is 12 meters. And we want to work out this length here. We'll call it x for argument's sake. No, we won't, because they've called that angle x. I don't want to confuse you. Let's call it y. Nothing wrong with calling it a different letter, but there is something wrong when you sort of use a letter they've already kind of stated. So we're going to use Sokotoa here, right? 5 is the angle we're using, so that makes that the opposite. 12 is the adjacent, so we're going to use Toa, tan, right? So tan, usually the bracket goes inside the tan. 5 equals opposite y, always opposite first, over adjacent second, 12. Let's solve this. Let's move across to 12. So y is 12 lots of tan 5. So, so if I do that, I would get 12 lots of tan 5, a negative number. That is very concerning. Why am I getting a negative number? It's because I've got radians on my calculator display. Yeah, always, if on your calculator, we don't always check this at the beginning of any calculator paper. You have been warned. If you see a capital, there should be a capital D at the top. That means decimals. If you see any other letter like a capital R or a capital G, reset your settings or talk to a teacher. I'm not sure if they'll be able to do this mid-exam, but they should be able to sort of help you at the beginning. You want to see a capital D at the top. If you don't, massive red flag. I had radians is something you explore at year 12 and 13, so you don't need to know much more than that for now. Right, but anyway, look, with the right value, I'm getting y is 1.0498. Okay, think about this. If angle x was any bigger, meaning, say it's 5 at the moment, and I made it bigger, like that green triangle, that length obviously here would increase in size, wouldn't it? So as a minimum, and of course, it's gone down all the way there, it has to be that value. Yeah? So I'm going to try once more. Yes. This length here is 1.0498. The AB is both the 2.6 and the number I've just found, 1.0498. So AB is 2.6. It's the combined height, isn't it, of the triangle and CD. So let's write that out. 1.0498 plus 2.6 gives me an answer of 3.6498. 3.64. 3SF would be the nearest hundredth, which rounds up because of 9 here. So it'd be 3.65 meters to 3SF. Okay. Let me confirm this with my mark scheme. I know you don't get this in an exam, but it's better than me sort of going back and realizing after I've posted it. All right, number 17. We've got we love rectangles. Is less than that. All right. This is called a quadratic inequality. Now, this is the toughest of the tough GCSE type quadratic equations. This is, in fact, I can tell you it's hard because it's a year 12 crossover topic, but you can do this. I believe in you. Year 11. All right. So, look, what do we know about area of a triangle? It's usually width times height. So even if you don't know the answer, please use brackets to just say that I understand the area is what you get when you multiply these two things together. Yeah. When you got two brackets side by side, us mathematicians, us examiners know, you mean you're timesing them. Now, we know it's less than 75. So look, inequality sign, strictly less than 75. Cool. You'll get a mark for that. Yeah. So even if that's all you do, even if you have not a Scooby-Doo, for the rest of the question, please write that. Yeah. Don't leave with nothing, right? Now, here's what we do next. We multiply out the double brackets. Remember, FOIL. We love FOIL, right? F for first terms in each bracket, 2x times x, 2x squared, right? O for outer 2. So the outer two terms in both brackets, 2x multiplied by -1 minus 2x. I means the inner two terms, right? 3 times x plus 3x is a positive. And finally, the last two terms, positive 3 times -1. Bam. Remember, inequalities, that's still less than 75, right? tidy up the left-hand side. We've got 2x squared minus, no, I don't, not minus, because minus 2 plus 3 is plus 1x, or plus x, minus 3 is less than that. Cool. Now, with quadratic inequalities, just like quadratic equations, we always want to have it equal to 0, not 75. So we're going to move the 75 to the left. So we'll take away 75 now from both sides. That means the last term will be take away 78, and that'll be less than 0. Cool. Okay. So the reason I'm pausing is I'm in my head thinking, does this factorize, or should I go ahead and use the formula? Do you know what? Let's run it through. Like, should I do AC method? So AC, I guess it's good practice, right? So remember your AC method, because the first number's not 1. I can't just do team. I need to do AC. So AC would be, well, A is 2, C is negative 78 minus 156, and let B, because there's no number in front of X, it's 1. So remember, AC means what two numbers would multiply to give that and add to give that. So I'm thinking of two numbers that are 1 apart that multiply to 156. Can I get that easily? That doesn't look too hard, you know. Let me try 12 times 13. Oh, I lucked out. Right, it's... Again, you can try different pairs of numbers, and if it looks like you're going nowhere, just use the formula, right? But bear with me here. So, I've lucked out. I've tried 12 and 13, and that gives me 156. They're also 1 apart, meaning the two numbers that it would be positive 13 and negative 12. Now, with the AC method, we always split the middle term, in this case 1x, into 13x and minus 12x, because that would add to give 1x. I'll copy out the first term, 2x squared, and I'll copy out the last term, 78. Cool. And then we factorize the first and last pair, right? So if I factorize the first two, the only common term here is x, and inside brackets, I'm going to write 2x plus 13. If I do the same with the second pair, love a bit pink, they're both negative, so I'll factor out a negative 1. Now, little pro tip here, I know that there's got to be, inside the bracket, there'll be a 2x. Why is it when I press the undo button, it always goes back to the beginning? Nightmare, people. Right, let's scroll down. I do not know why my iPad likes doing that, but hopefully that gives you a bit of a breather. Fast forward if you don't want to see me scroll forward or down. Oh, what a pain. Right. Yeah, as I was saying, I want the bracket to be 2x, don't I? So I know 6 is the number that needs to come out, right? So minus 6, bracket, positive 2x, right? Because minus 6 times 2x is minus 12. And, well, how many 78 is going to 6? I'm going to be lazy and use my calc here. That's slang for calculator. It's going to be 13. And it's a positive 13, right? So less than 0. Cool. Now, when it comes to double brackets, because this is where this question is heading, the coefficients of your first two brackets makes up the first. So it'll be x, take away 6 goes in the first bracket. And then the second one will be what was common factor in both. So it'll be a 2x plus 13 because that's common to both. And less than 0. Okay, cool. Now these, we are going to find the critical values. Now, why am I not saying solutions? This is not an equation, it's an inequality. So the critical values are when this bracket equals 0, which would mean the first critical value is 6. And the second critical value is not going to be a whole number, but in fact, it will be minus 13 halves. All right. Now, why am I saying critical values? Well, think about it. This original expression is a quadratic equation with a positive coefficient of x squared. Now, the number in front of your x squared is really, really important because if it's positive, it makes a U shape. I always like to think positive means happy face. Now, if the number in front of the x squared was positive, it was minus 2x, that would be negative. And what do we know about negative? We know that they are sad face. So that's why I know the shape I'm about to draw is a positive and it's a U shape as opposed to more sort of a upside down N shape, lowercase n. So these critical values mean this. It means your smiley face is going to go through the values 6, and you don't have to be accurate here, and minus 13 over 2, which as a decimal would be minus 6.5, sorry. We can use this. It doesn't really matter which, right? But it would be this sort of classic U shape. Yeah? Because 2x squared is positive. Now, look at this inequality. When is this inequality less than 0? When does this smiley face of mine dip below the x-axis? Well, it's here. It's this region I've just shaded in. And that happens when x is greater than negative 6.5, but less than, right? If you're bigger than that and bigger than that, this inequality will hold. So to wrap things up, x is greater than minus 6.5 or 13 over 2, if you want to write a fraction, but less than 6. Okay, you do copy that inequality sign. So quadratic inequality, super tough question. 17, this seems a bit early for this level of difficulty in a real GCSE, but again, this could come up on a nasty year. It might come up. Now, my mark scheme, interestingly, says 6 and minus 6.5. Wow. I don't get this. So it's factorized it the same way I've done it. And again, I'll post this online. The mark scheme says this. So it says this. Let's try and work out. Sometimes in the mark scheme get it wrong. I may have not read a detail at the end. So the mark scheme's saying this. I'm saying this. The number on the right's the same, but the number on the left's wrong. Why? Here's why. And again, not that I made any mistakes in my working, but what I haven't done is I haven't thought about the context of the question. We're talking about areas, aren't we? We're talking about areas of specifically rectangles, right? So this is 100, I haven't made any mistakes, right? This is a good inequality, if I do say so myself. However, what it doesn't consider is the rectangle. These two sides of a rectangle always have to be positive, don't they? Do you know what I mean? So we can say also 2x plus 3 has to be greater than 0. So 2x is greater than 3 minus 3, sorry. And then x has to be greater than minus 3 over 2. Of course. But also, this length right here, and this is where you'll see the mark scheme is spot on, and I would have probably lost marks for this oversight. This height, x take away 1, must be positive, right? So if I rearrange this, x has to be bigger than 1. Now, in the world of inequalities, we kind of have to make sure all inequalities are happy, right? So what I mean by that is we have to make sure that this is happy, and ultimately the bottom one here is happy. Now, the problem with saying minus 6.5 is if you use minus 6.5, it would result in you having a negative height. So this inequality would not be happy, the fact that I said minus 6.5. So you kind of have to say, for what values would all three inequalities hold? And that would be x is greater than 1, because x greater than 1 is sort of already allowing x to be greater than negative 3 over 2. So we've got to think about which is the strictest three inequalities. It's the 1. So we need to update this inequality, right? It's, yes, x is less than 6, this bit, but x is greater than 1. So, yeah, I would have lost marks because I did not consider the context of the question. Really, really tough inequalities question. If I saw this in an AS Year 12 paper, it would not look out of place, right? But again, it is technically on the GCSE spec. You have to be ready for it, I'm afraid, but it would be one of sort of the harder years if I saw that. I would say, wow, you guys got a raw deal here. All right, number 18. Circle theorems at first glance. EOG is a diameter. We love diameters. DFG. DFG. Okay. This angle here. Okay. Right, circle theorems question. We've got a diameter. DFG. State each reason. This is tough because even top students miss out keywords. I'm going to show you how to get it right every time. Okay. So, to be fair, most of the marks are from the right number, but if you want to get those 100%, if you want to ace this test, you're going to have to give the reasons. All right. So, keywords. I will let you know what those keywords are. So, look, I don't know the answer yet, but here's what I do know. EOG is a diameter, right? That's really, really important. So that green line I've just drawn makes a semicircle. Now, I know straight up that angle there. So let's write angle EDG equals 90 degrees. Now, my reason is, and you can write this in brackets, angles subtended. They like the word subtended. Basically means hanging off. And you can use either one of these two words, diameter / semicircle. I think diameter is a better one personally. Equals 90 degrees, right? So either word, I think diameter is a better word to use. But again, you're hitting keywords. You're saying that or that. The examiner will say, and you got to say 90 degrees, right? Or right angle. If you're not saying these keywords, you will not get the reason, the sort of communication mark at the end for your reasoning. Cool. So we can add that, a little 90 degree or a square if you want. And for the same reason, EFG. To save time, I'm not going to write. It's the same reasoning, right? It's sort of a semicircle but the opposite end. Okay. So, let's see. Am I any closer to DFG? DFG. No. What can I get from this? Okay. Right, do you know what? Let me rub out some stuff. Because it makes it a little bit easier, right? So, I don't know if this squares are really going to help, but okay. Sometimes you kind of work these angles out and you realize they're not useful. Okay. So look, this 42 degrees here is these two angles are sort of hanging off this arc here, aren't they? Or you can say sector or arc, it doesn't matter. But the idea is that ED are 2 points of an arc or a sector, and you kind of drawn two straight lines from D and E to get third letter G. Are there any other angles that we can make using D and E? Yes, there is. It's that angle here. Look, if we draw a straight line from the same two endpoints, D and E, we would get that angle right there. Well, how about that? So we know that is also 42 degrees. And here's a reason. So we could say angle DFE, my bad, is DFE is 42 degrees. And my reason is angles subtended by the same. And you got a choice. You need to say arc or sector. Segment, sorry. Not sector. It's not a sector, it's a segment. Are equal. You can use either one of these words. I like arc. Segment. Doesn't matter. Don't use sector. Sector's like a slice of pizza. This does not go through the center of circle. Do not use sector. I implore you. Anyway, there we go. So I'm breaking it down. I'm working angles out here. So how far am I? Am I any closer to DFG? Yes, I am. Because remember, I said earlier on EFG was 90. That angle there is 90. And I know that angle there is EFG. Now, so what we can do to finish this off is we can say DFE plus DFG, which is this angle here. They have to add up to 90 degrees, don't they? Right? So we could say that angle DFG. Now, what's the reason? Is it complementary or supplementary angles? I always mix these up, the reasoning. Let me do a quick Google search. Oh my God. The reason I'm Googling it is I always mix those two up. Yeah, complementary angles is the reason. They add up to 90 degrees, don't they? So my reason is complementary. Add to 90 degrees. Meaning angle DFG is going to be 90 minus 42. So 58 degrees should be, 48 degrees. What am I talking about? The correct answer. Let me look at the mark scheme. Please be right. And we'll be on our way. Now, I will post the mark scheme because these questions often have more than one correct reasoning. They did it in a slightly different way. So feel free to sort of move on, fast forward it. But you know what? As a little bonus, again, look, if you did all that, you're going to get 4 marks, right? The answer is 48. I've used very good reasoning here. I've hit all the keywords. Happy days. There is an alternative method. Fast forward to the end. Maybe you did it this way. But yeah, look, don't panic. If you did yours differently to mine, you're good. You're good. So, well, I say that. Hopefully you used the correct key words here. I'll show you how they did it. Okay. So let's explore how they did it. Okay. Okay, yeah. So what they did here is they drew an extra line, and this can be really, really useful sometimes. So here's how they did it. You can draw the extra line OD in if you want, and you can work out that angle there, which is 84. So we're going to say angle DOE is 84 degrees, and the reason behind that is angles at the center are twice angles at circumference. So yeah, what I mean by that is that if you see that angled out there, they're hanging off endpoints D and E, but they're drawn at the center. Again, if we use D and E as my endpoints, this also goes off D and E, but it goes to the circumference instead of the center. So they have that relationship, don't they, these circle theorems? Again, circle theorems is actually one thing I want to teach very, very shortly in class. So rather than bamboozling them with loads of questions now, do hang tight and I will explore this in more detail very shortly. So that's 84. Cool. Now, next up, how's this going to help me work out DFG? Okay. Right, we can say angles in a straight line, can't we? So we can say angle DOG, where are my dogs at, is going to be 180 minus, isn't it? It's angles in a straight line, so it's going to be 96 degrees. Okay, I would, you know what, let's not be lazy, 180 minus 84. Angles in a straight line. So let me write 96. Okay. Now, we're one step away, would you believe it? And if you can't spot it, don't feel bad. See, look, we've got an arc here, and to draw 96 degrees, we draw two straight lines towards the center from DG, there and there, to get 96. I'm not gonna need this 94 anymore, 84 anymore. Now, angles at the center, we've already said this, are twice angles at the circumference. So using the two endpoints D and G, I'm going to draw a straight line from D, from G, but instead of the center, I'm going to go circumference. And what do we know about that? We know that angles at the circumference are half. So 96 divided by 2, would you believe it, is, yes, you guessed it, 48 degrees. So it is the same reason I'm not going to bother writing it again. In an exam, I would write it twice. But yeah, angle DFG equals 48 degrees for the same reason as stated above here. In a real exam, write it out again. Don't leave anything to chance. Yeah, also worth full marks for this alternative approach. Now, I've gone through two approaches. There might even be a third or a fourth even. You know, we've got work to do, so find out in your own time. If you've got a third method you want me to have a quick glance, I'll let you know if it's worth full marks or not. Okay, 12. We've got we love histograms. One thing I always think about with histograms, you can memorize the formula. I always say the frequency is always the area of the rectangles. This always helps me remember the formula. If I just remember this, frequency is always the area. Meaning, well, that's the class width. How wide your bars are the class width times your frequency density FD. Right, I don't even bother memorizing the formula anymore, but I just remember that the frequency on its own, frequency, no frequency density malarkey, is class width times frequency, because it's the area of the rectangle, right? Cool. All right, what do we know? We know 12 tomato plants are between 75 and 85. So it's this bar here, isn't it? This has an area of 12, because that's the frequency, remember, right? 12 tomato plants is your frequency. So that's going to help me find the scaling of the y-axis. So I know that the bar is 10 wide, 10 times y is 12, it's got to be 1.2, right? So the height of this is 1.2. There, because the width is 10 times 1.2 is 12. And that's going to help me scale, right? So what's the scaling? What's going on here? Okay. So every 2 squares is 0.1. So this bit here is 0.5. This is 1. Yeah, every little 2 boxes is a 0.1. So this would be 1.5, and there'd be 2 at the very top. Cool. Estimate has okay, right, cool. So let's work out all of my frequencies. So work out all the areas of all the rectangles. 12's given to you, so you can be a bit lazy there. This rectangle here is a width of 5, height of 0.4. So times those two numbers together. You are allowed to be lazy here. But do write the working out, right? Do let the examiner know where these numbers are coming from. Because if you press a wrong button in your calculator, it'll ruin the whole question. But if the working's there and the examiner says, oh, yeah, they were just being a bit careless with their calculator, you probably only drop 1 mark, right? So that's 2. Cool. This middle bar here is 5 lots of 1. You don't really need a calculator for that, do you? 5. And this bit here is 10 times 0.6, 0.7, 0.8. So that would be, again, if you need a calculator for this, I worry for you, it's 8. And last bar, 5 lots of 0.6 is 3. Did I say 3? Yes, I did. Okay, we know the total now. So I'm going to rub out all the little bits of working. I'm just interested in frequencies here. Estimate probably. Okay. So what's the total? Because, with probability, we want total amount, don't we? We want the total. Well, it'd be 3 plus 8 plus 5 plus 12 plus 2. So in total, total number of my plants is 30 plants, right? So when it comes to my probability at the end, I'll divide by 30. Okay. Now the question says greater than 82.5. So looking at my histogram, 82.5 would be here. Greater than this. Well, we know this rectangle's 2, but we will need to estimate part of this sort of second bar. Now, there's 2 ways to do this. You could say, oh, well, that's a quarter of my bar, so it's going to be 3, isn't it? Fair enough. But look, another way is this second bar here, the width would be 2.5. The height would be 1.2. So you do your 2.5 times 1.2 is, it's 3, isn't it? So look, it'd be 3 there, 2 there. We'd expect there to be 5 plants greater than 82.5. This is a probability question. So the chance that you pick these is, so the probability is going to be 5 out of, well, there's a total of 30, isn't there? So it'll be 1/6 is your probability. This is the final answer. At least I hope so. Let me double check. On my mark scheme, it is correct. Right, surely. All right, we're down to the last question, people. You made it this far. Let's look at similar shapes. Wow. You know what? Compared to what we've already answered, question 20 is relatively chill. Or at least that's my first impressions. There could be something devious about this. Okay, so let's talk similar shapes, right? This is a topic you want to explore if you want to know more. Similar shapes, but look at sort of linear, area, volume, scale factor. Because if you type just similar shape, this is a fairly chunky topic, or unit rather. So type in linear, area, volume, scale factor with similar shapes. So there is an added flavor to this. Now, usually with linear, meaning lengths, we divide, right? So the scale factor here is 15 over 10, or if you simplify, 3 over 2, or 1/2. 1/2. I'm going to keep it as a fraction. You'll see why in a minute. Now, with area scale factor, we usually square this. So we would take my fraction, 3 over 2, and square it, and you get 9 over 4. These questions are actually, they're quite popular on non-calc papers. So it's handy to sort of leave as a fraction and square it, because that's way easier than squaring 1.5. I get that a calculator could do that, and it's 2.25, but without a calculator, it's how you do it. Cool. Now, because of volume, I'm probably not going to need the area scale factor, but I'm going to do the same 3 over 2, but I'm going to cube it. So this will be 27 over 9, sorry, over 8. Again, I'm not going to bother with that as a decimal just yet. I mean, if you want to write it as a decimal, go crazy, but I'm going to leave it as 27 over 8. Okay. Now, before you get excited, this is not... Okay, so this is a bit more trickier. Usually, if you were given the volume of the small or large shape, you would just either multiply, divide by that, 27 or 8, and life would be easy. Alas, it is not that simple. So let's just say this, right? Let's just say the volume of A, let's just call it X, and the volume of B. Now, using this fraction, we would usually say, well, usually you'd multiply it by 27 over 8. You'd get 27 over 8 lots of X. Now, it tells you the difference between the volume of A and B is this number here. So difference usually means we subtract these. So what you want to do is you want to take 27 eighths of X, and we will take the original amount, which is X. And as a result, we will get 1197. Now, let's simplify this. 27 eighths take away 1 is, if I do this with my calc, because I'm being lazy, 19 over 8x. 19 over 8 lots of x. The original size of ours, A, is 1197. So to work out the, let's rearrange this now to work out x. So we'll times by 8, and we'll divide by 19. And then type all of that in, and we shall get the value of x, which is the original volume of A. Is it going to be something nice? 504 centimeters cubed. Now, let's reread the question now. What's volume A? Sometimes, we're quite lucky here. It's always important to reread questions, because I have seen questions where you do all of this work, you get really, really far in, and the question says, oh, what's the volume of B? And all you've done is give volume A. So if, and I know it's not the question, but I'll explain anyway. If you're asked to find volume B, obviously you just take that number and just multiply it by 27 over 8 again, and you'll get your B, and it'll be whatever. But I'm going to just stop short here because that is the answer. So well done if you got this far. We made it to the end. Did you get 80 marks? Do you have any questions? Is there anything you'd like me to do a bit more detail? I have confirmed just by glancing at the mark scheme that is correct. Give me some feedback. Some sort of quality improvements, hopefully, on your end. I've sort of now got an actual proper iPad pen. I'm doing it in landscape, so hopefully you can sort of see everything that I'm writing and talking about. And I'm recording with my AirPods. So do you like the microphone on my AirPods? Do you prefer the speakers, the microphone on my iPad? Let me know.